So in the last video, we looked at an input device and it represented, for example, a keyboard. In this video, we're going to look at an output device, and this would represent, for instance, a monitor. Now, the circuit is actually designed here. I'm not going to talk through the full design the way I did in the last video. It just takes a bit too long, and it's a very similar design. So this here is just the same as in the input device. We need some way of addressing the device, and you'll note here that the address of this device is different from the address of the previous device. So in order to address this, we're going to have 1, 1, 1 and 1, and you can see this point goes high. So for the input device, it was different. We had it set up as these 4 ones. Okay, so that's the first thing that's different. Now this is just a bit random, this choice I've made. Okay, so you can make any choice that you want, and you can design your output device and input device addresses as you want. Now this section here is just exactly the same as the input device. So this is the method we use in order to address the device. So first of all, the device has to be reset. And after it's been reset, we address a device by making the I/O high and the data address high. So those two go high. And then we're going to wait for the set pulse to come along. And it comes along, goes high, it goes low, and you can see now that this side here is now set. So now we've worked through the process of choosing this device, and we see this line here is going high. We're using this device as an output device, so for example like a monitor. So it's expecting to find information coming from the CPU into it. So it's going to get that information again from this point. So let's say the information now changes to something like this value here. So that information is changed to that value. We're waiting for this information to be set into this register. So in order to be set into the register, this set has to go high. So first of all, we have to be choosing this device, and we are choosing it because this is going high. And then we're going to have this other line here, which is controlling this set. So this other line here comes again from our truth table. So in our truth table, we're going to be outputting data from the CPU whenever the I/O is high and the data address is low. So again, you can check your truth table for that. So that means we're going to get 1, 1 on here. And again, we're waiting for the set command to go high and then for it to go low in order for us to set it into this device. So the set is going to go high, and you can see here we've now passed this data into our little register here, and then the set is going to go low, and we're going to hold that data here. So that's us pass the data from the CPU into this device. So you can go ahead and you can build both of those circuits, and then you can create the hierarchy from them. So I've created something called CPU input device, another one called CPU output device. And these are the two devices that I have here. So this is the input device here, and this is the output device. Now I've just shoved the bus back up to this position up here, just to give us a bit more space. So what we want to do is go through a couple of programs just to test this. But now as it stands, I haven't built this functionality into the assembler debugger. I will do that over the next couple of videos so that that's available. But until that's available, what we'll do is we'll just actually write the code in. Okay, and I've already worked out the code that we require in order to test this, and we can check and see it's working. So let's go ahead and we'll do that now. Now, one other thing to note before we get started, I had to create an extra pin on this level here, because now we're going to have a bus input as well as the bus output. So I've put this bus input pin, and you can see that on the top level. If we head up here, you can see here there's 1 if I make it a bit bigger. We've got a bus input pin here. So now let's have a look and see how I've connected these up, because we want to make sure we know how to connect them. So we're going to have our 4 outputs here. So we've got our set and our enable, and we've got our input output data address. So we've got our input output data address, our enable and our set coming to these inputs here, and also the reset. Now we've got the same thing over this side here, because we have to address both devices just in the same manner. So we're going to have our reset, we'll have our input output data address, enable and set. So those are quite straightforward. Now the input device is expecting us to actually input some data, so whenever we run through a simulation we can stick the values, say all ones. So all ones would be FF and hex. Now this is where the input comes from. The output from this has to go back into the CPU. So I've just called the output from this data. So it's going to come out from here and it's going to come back into the CPU. So it's going to go to the bus input. So that data there goes to the bus input. So that's a line from here back into the CPU. But now we've also got to make sure that we can address this device as well. So we're going to have the address line coming out from here, from the CPU, and the address has to go in to choose this device. So we can see here we've got this bus in. So we're going from the bus output here, so we're coming out of the bus, round and in to the device here. So that's all the connections that we need for the input device. Now the output device, the only other connection here is we're going to take the data from the CPU into this device. So again, we're going to go from the bus output, which I've just called bus, round and into this device. Now the data output here, we're not bothered about that because we're treating this as an input, as an output device only. Okay, so we're not bothered about taking this output anywhere. So that's how both of them are connected up. Let's run through the simulations. Now I've generated the code for it here, and whenever I work through the code I'll explain what each of them are, but you can also go ahead and try and work this out for yourself from the truth table for our instruction, and you can work all this out for yourself. So let's go ahead and we'll do that. So the first thing we're going to do is we're going to take the data from this input device, so this is like our keyboard, and we're going to take it and place it into each of the registers here, R0, 1, 2 and 3. So we're reading data in from the keyboard to the registers. So the data, as we said, that we're going to read in will just be all ones. So it means that we'll get a value of FF in the registers. Now in order to do this, we're going to have to first of all address the devices. And to address the devices, we address them from a register. So in order to do that, we have to have the address actually in the register. So we can put the data into the register. So 20 is actually the data command. So that's data, and if we put 0f, so that just puts the value of 0f into register R0. And then we're going to use 7c. So 7c is the new command that we have in order to address to put an address on the output. So we can get that 7c because we know that the first 4 bits of this new opcode are going to be 0111. Okay, so that tells us we're going to have a movement of information out or into the computer. So 0111 is just the value 7. So all of these new, these 4 new codes that we have all begin, or instructions that we have all begin with a 7. So the other part of it is the C part of it, okay? So the other part of it just tells us, the other 4 bits tells us whether it's an input, output, data or address, and then the last 2 bits tell us what register we're going to or coming from. So that there just sets up the, puts the 0F onto the bus, and it registers the device. So in this case it's going to register the input device. Now what we're going to do then is we're going to shift that data from that device into the memory. So we're going to shift it into 7.1, 7.2, 7.3 and 7.4. Now it's a good idea for you to sit down with the instruction for the new instructions that we have, and you can see that these do actually apply, and you can see where these come from. Now when we've done that, we can put in CF and that finishes it. So if this all works out right, so we'll go simulate tick enable and we'll run through this simulation. So we're expecting to see the value FF appearing in the registers. FF, so there we go, we've got FF has been read into these registers here. Now if you want, you can take this code that I've given you there and you can run through it one step at a time just to see the movement of the information round about the CPU. But I'm not going to go through that here, it will just take up far too much time. So that's one code that you can write in. So we can, let's reset this here and let's run a different one. So this test here is going to take the value of our 1111. So it'll take our FF, it'll take the FFF and it'll load it into the registers, okay, and then it'll read it out of the register and into the output device. So this is like typing in something in your keyboard and it goes into the CPU. The CPU then works on that information and then it pumps the information back out and onto a monitor. So the code that we need for this is going to be 20.0F 7C. Okay, so this is the registering. So once we've registered it, we're wanting to do the 7.1, which is load the data from the input device into the CPU. And then we're going to have to go through the process again of addressing another bit of equipment. So we're 20, in this case we're addressing F0. So F0 is the output device, and then we're going to have our value for our 7C, and then finally what we want to do is read that data into the output device, and we do that with a 7.9, and the final value is our CF. Okay, so you can take a note of those and you can try this out for yourself and you can work through it one step at a time, but I'll just simulate now. So simulate, tick enable. So if it works out, it should take the 111, it will put them into a register up here, I'll read out this register and then it'll put it into the output device. And there you see, that's it, done it now. It's taken the value FF which we've typed into our keyboard, it's put it into a register up here, R1. It's then read this register out and it's put it into the output device, and that's it in the output device. So this process of inputting and outputting data onto these devices works, and we could create as many of these input-output devices as we want. We just need to generate the address for each of them. But that's only a part of what we're doing here just now. We really want to try and simplify things a lot. So we can then say to ourselves, well, if I can get information into and out of the CPU using this process, why do we bother with this external RAM and loading things up and loading the program up? And why do we bother with this here, the counter, in order to count it in? And why do we bother with this internal RAM here? We could just take it outside and we could just get information in and out of the computer using this process. And that's what we'll look at in the next video. And this is where we'll see the power of what we've done over the last few videos and see how much it simplifies everything for us. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.